Okay, here's your key to problem set 0. I've broken this up into 3 different videos because of the length of the problem set. I figured that might help you. So number 1 says sketch a non-horizontal, non-vertical line on a coordinate grid and find its slope. So just sketch any line that you want. Okay. And then plot a couple points. And then just count the slope. I'm just going to make mine up. Let's say this is at 5. This is at 2. So remember, slope is rise over run. So my slope here is 2. So let's say this is at -1. So my slope would be 3/5. Okay, what do we know about parallel and perpendicular lines? If you recall, parallel lines have the same slope, and perpendicular lines, that's the symbol for parallel, by the way, that's the symbol for perpendicular. Perpendicular lines have opposite reciprocal slopes. We will actually use this idea quite a bit in calculus because we're going to learn about what's called tangent lines and normal lines as well. Normal lines just means that they're perpendicular to each other. What do we know about horizontal and vertical lines? A horizontal line, I'll just draw horizontal. Horizontal line has a slope of 0. And a vertical line, the slope is undefined. And there's a better version of the key that's written out by me. This is more for you to be able to hear. So I'm going to use a lot of like shorthand notation and stuff like that just to make it go faster. Equations for a horizontal and vertical line that passes through the point 7, -5. Remember a vertical line. So a vertical line is x equals. And so that was going to be x equals 7. And your horizontal line is always y equals, in this case y equals -5, because that's the y value of the point that it passes through. Alright, number 2 is an interesting question that a lot of people have never been told, but this is called point slope form. If you remember, we're going to use this a lot as well. So those of you who like to use y equals mx plus b, you might want to get used to this form because it's actually easier for the stuff we're going to do, even if you're not used to it yet. But if you take both sides and divide by x minus x sub 1, you end up with m equals y minus y1 over x minus x sub 1. Now normally you see it written like this with like an x2 and a y2. I mean, those are just arbitrary labels that represent different variables. And that's exactly how you find the slope between 2 lines, or 2 points. And so this is a formula that you've known forever, and then all of a sudden somebody introduces this point slope form to you, but never makes that connection. So it's just interesting, I think, to see where that comes from, if you've never seen it. Okay. 2a, find the equation of the line with a slope of -2/3 that passes through point -3,5. So I'm just going to use point slope directly and get y minus 5 equals -2/3 times x plus 3. It's x minus -3, so it becomes x plus 3. The beauty of point slope, and for the most part how we're going to use it, is we're done. That's all you got to do. You just plug in the values. Okay, now b is the same question except we need the slope first. So let's find our slope. Our slope is equal to -5 minus 3/4 over 8 minus 1/2. Or you could write 3/4 minus -5 over 1/2 minus 8 if you really wanted to. Okay, our numerator is -23/4 over 15 halves, which, saving us some time, that does simplify to negative 23/30. You're going to see me do random things on here because I'm still getting used to this particular app writing on here. And now you can use either point that you want and use your point slope, y plus 5 or y minus negative 5 equals our slope, negative 23/30 times x minus x1, which is 8. And again, you can just leave it in that form. Part C, write an equation for the line through negative 1, 2 that is parallel to that. So if it's parallel, we talked about earlier how that means they have the same slope. So if they have the same slope, and we know the point, we just do y minus y1 equals slope times x minus x1. And that's it. That is point slope form. Oops. And if it's perpendicular to that line and still passes through the point negative 1, 2, then we know it's going to be y minus y1, and our slope is opposite reciprocal, so negative 1/3 times x plus 1. Again, you can just leave it in that form. So we're going to build on that idea as we go through calculus a little bit. We're going to work on these things, like I said, called tangent lines, and we're going to find the equations of those lines, and we're going to use point slope form when we do it. All right, number 3, the relationship between Fahrenheit and Celsius is linear. Find the conversion equation using the information given below. So really, what we really have here is just 2 points, and it doesn't matter what you call x and what you call y. I'll let Fahrenheit be our x values and Celsius be our y values, giving me these 2 coordinates. And then with those 2 coordinates, we got to find the slope. So 100 minus 0, which is just 100. I'll write it all out for you. Over 212 minus 32. That's our slope. Let me make that look a little better. It won't let me erase that. Well, oh, that's not what I want. 32. All right. Reduced is 5/9. Some of you might know the conversion equation, so you might recognize the number 5/9. And then we can just use our point slope, where I'm going to use C for Celsius, which is our y values, and F for Fahrenheit, which is our x values. So y, and I'll use the first point because it has a 0 in it, which makes it easier, equals slope times x minus x1. And so that's just C equals 5/9 times F minus 32. And there you go. That is it for page 1. Okay. Number 4. What is a function? Just a reminder that a function means for every input, there's exactly one output. So I'll just say input yields exactly one output. Or for every x, there's only one y. Function notation, just a quick reminder of what that is. Which is, we write it like this, and it just says, how is this read? It's read as f of x is how you say that. F of x, just a quick reminder of function notation. Okay, then you have the independent and dependent variables. In this case, r is our independent variable, because right here you see we have a as a function of r. The area is a function of the radius. So r is independent, a is dependent, which means the area depends on the radius. And that is the y. I'm not going to write that. Find the area of the circle in terms of pi whose radius is 4. So what it's really asking us to find or evaluate is a of 4. So that's just going to be 4 squared times pi, which is 16 pi. Alright, now some basic functions and finding domain and range. Write the domain of the following functions in two different ways, one using inequalities and the other using interval notation. So the inequalities, we'll see it sometimes on some stuff we're going to do, so it's just a reminder, but you can use interval notation on all the problems if you want as we go throughout the year, but I want you to use both on this just as a reminder of how to use interval notation. So interval notation is kind of weird since the domain of this is all reals. You can write it like this if you want, or perhaps you've seen this notation, which means all real numbers, and then an interval notation is just negative infinity to infinity. For part 2, as an inequality, you can just say x is not allowed to equal 0, because that's the only domain restriction, because you can't divide by 0. Or an interval notation, that's negative infinity to 0, union 0 to infinity. Number 3, inequality is x is greater than or equal to 0, because you can't square root negative numbers, but you can take the square root of 0. Sometimes people get confused on that. And then remember we have our inclusive bracket on 0 to infinity for interval notation. Number 4, now since it's 7 minus x, 7 is what makes it 0, but then any number bigger than 7 would make it negative, like if you plug in 10. 7 minus 10 is negative 3. So we actually have to choose numbers that are less than or equal to 7, which in interval notation is negative infinity to 7, bracket on 7, meaning you can include 7. Okay, number 5 here is very similar to number 2. We just have a vertical asymptote graphically, so we should know that x is not allowed to equal 2. In interval notation, that is negative infinity to 2, union 2 to infinity. And then number 6 is similar to number 5, except we have 2 restrictions. So if we factor this, we get 1 over x plus 3 times x minus 2. So in inequality, we can just say x not equal to negative 3 or negative 2. And in interval notation, you go negative infinity to negative 3, union negative 3 to negative 2, union negative 2 to infinity. Like that. Okay, number 7, you need to find the domain and range using a graphing calculator. You might be able to do domain here without a calculator, and if you can, that's great. But our domain here is negative 2 to 2, because negative 2 and 2 make it equal to 0, but if you go above 2 or below negative 2, then you'll get negatives on the bottom. So you have to be between negative 2 and 2. Now the range here is interesting. And I've probably, if I haven't explained this in class already, I will. But to how to do the range without a graphing calculator, if you have a fraction, then the bigger the denominator is, the smaller the number. So, for example, if you have 1 over 100 compared to 1 over 2, well, 1 over 100, which has a bigger denominator, is a smaller number. And so the bigger the denominator gets, the smaller the number. And so what we're trying to find is the smallest number that our denominator will be right here. So if we want the smallest number down there, then we want our denominator to be as big as possible. And the biggest our denominator will ever be is if we plug in 0 for x, because then you do 4 minus 0. And so if the biggest our denominator will be is when x is 0, then you get 1 over square root of 4 when x is 0. I don't know why it keeps disappearing. And you get 1/2. So 1/2 is the smallest value that this will ever be, because that's when the denominator is at its biggest. And so our range algebraically is 1/2, and then to infinity, because what happens as x gets closer and closer to 2 from our domain, we know it's going to get infinitely close to 2. That means we're going to get infinitely close to 2 squared. So we're going to be really close to 4. And then in here, if you plug in a number really close to 4 for x squared, or a number really close to 2 and square it, and you get something really close to 4, then 4 minus something really close to 4 is really close to 0. And as you get closer and closer to 2 and square it, you're going to get closer and closer to 4. And when you do 4 minus that, you're going to get closer and closer to 0 forever. And if you're getting closer and closer to 0, that means you're becoming a smaller and smaller number. And 1 over a small number, as your denominator gets smaller, as we talked about up here with 1 over 100 and 1/2, as your denominator gets smaller, the value of your number gets bigger and bigger and bigger. And that's going to occur forever, which is how algebraically you can figure out that the range will actually go to infinity. All right, and then number 8, we're just going to sketch graphs of these basic functions and then state the domain and range in interval notation. So y equals x, you should know is that. Domain and range are both negative infinity to infinity. Okay, b x squared, you should know is a quadratic. The domain is all reals again, are negative infinity to infinity in interval notation, and the range is 0 to infinity. C is x cubed. X cubed, you should know, looks like this. And again, the domain and range are both negative infinity to infinity. Okay, D, 1 over x. You should probably know that looks like this. Oh, there we go. And we have a domain restriction on this one. X is not allowed to equal 0, so that's negative infinity to 0, union 0 to infinity. And the range is the same thing, negative infinity to 0, union 0 to infinity. E, the square root function, that's like half of a sideways parabola essentially, because those are inverse functions. So it looks like that. The domain and range are both 0 to infinity. Domain and range inclusive on 0. So I'll draw that in there with a clearly defined point. Cube root of x is the inverse of x cubed. If you remember, inverses graphically are reflections over the line y equals x. That might be meaningless to you, but that's just a quick reminder, so if you hear that again. Domain and range, both negative infinity to infinity again. And then 1 over x squared looks a little funky because when it's x squared, everything will be positive. So it looks like this and like this. And you can figure out why this graph looks the way it does by using the same logic we used on number 7 algebraically to figure out the range, how we talked about really small numbers on the denominator and really big numbers on the denominator and how that affects the value of the function. But in any case, our domain, you're not allowed to equal 0, so it's negative infinity to 0, union 0 to infinity, but our range is just 0 to infinity. Alright, and that is it for the first 2 pages. There are 2 other videos for this problem set with 2 more pages each.